Maddie's got it.
Okay.
All right. Oh, welcome everyone to this edition of NAPHN Live. Really happy to have you here with us. My name is Ken Levinson. I'm the Executive Director of NAPHN. And today's event is being hosted by New Jersey Passive House, regional chapter of NAPHN. And we're really happy to have them hosting. It's going to feature a project in Hoboken, New Jersey called Candela Lofts, the first certified passive house multifamily in New Jersey, and really a game changer for the area. We're presenting John Nastasi of Nastasi Architects, Ed May of Building Tip, and special guest appearance by Michele Cabrisi from New Jersey's Clean Energy Program and Clear Result. So we'll come back around and introduce them a bit further. But first, I want to just take a moment to introduce NAPHN a bit further. So we are a national nonprofit.
Oh, Ken, you're muted, I think.
You didn't hear any of that?
We only heard you say NAPHN is a nonprofit.
Oh, okay. Sorry. I don't know how I got muted.
It's okay.
So NAPHN, we'll edit that. NAPHN is a national nonprofit. We're focused on education around passive house standard and building peer knowledge sharing networks across the country and around the world. We have local chapters as well as a catch-all national chapter now called Passive House America for those that don't fall within any of the distinct regional chapters. And we are looking to grow the regional chapters as well. We are affiliated with the Passive House Institute in Darmstadt, Germany, the International Passive House Association, and work closely with the North American Passive House Certifiers Circle, group of professional building certifiers. So we encourage everyone, if you aren't a member, to become a member, and we want we're so happy to have member involvement in everything that we do. So a quick shout out to our sponsors, and we're always looking for more sponsors. These are national sponsors to our efforts: Rockwool, 475, High Performance Building Supply, Need Based, and Zola Windows. So very happy to have them on board. Couple of quick announcements very briefly. This November 6th to the 8th is International Passive House Days. Go on the events calendar, go on the passivehouse.com IPHA calendars and find out all that's happening. On November 16th, NAPHN will be having its next CPHD course, which is really the core foundational course to be practicing in the passive house environment. It's online, completely accessible. I encourage everyone who hasn't taken it to take it. And then each Thursday, if you're looking or you know somebody who's looking to find out a little bit about passive house and get their feet wet and find an easy on-ramp, I do a 1-hour intro to passive house, alternating between 12:30 p.m. East Coast time and noon Pacific time. This Thursday, it's at 12:30 East Coast. So with that, I am going to hand it off. It's my great pleasure to hand it off to Sean Torbert from New Jersey Passive House. Take it away.
Thank you, Ken. Very much appreciate the introduction. If I could just add one thing to the Certified Passive House Consultant Designer training. If there is a silver lining to all of this COVID-19 stuff, it's that you can do all of the training remotely. So if you're looking for something to do, I highly encourage those who haven't taken the training to become certified passive house consultants and designers. So very excited about the presentation today. It's been a long time coming. Some of you may or may not know, but this was originally scheduled to be a live event and tour at the Candela Lofts in Hoboken. But we actually decided to cancel it when the COVID-19 shutdown started. So, absolutely thrilled that we're able to do this, even if it is remotely, and certainly appreciate Ed May and John Nastasi for doing this with us. So quick, little intro to New Jersey Passive House. We are the chapter under the North American Passive House Network. So the North American Passive House Network we're under that umbrella. We've been active in New Jersey for, gosh, I'd say, 5 years or more at this point, but officially signed our charter a couple of years ago under the North American Passive House Network. So it's our goal to really spread the gospel of Passive House and the Passive House standard as an essential tool to meet New Jersey's climate action goals. Places like New Jersey, about almost 70% of our emissions come from the built environment. And, Governor Murphy has laid out these goals for 2035. To be 100% renewable and 2050 to be, carbon neutral. The truth of the matter is that we can't get there without addressing our built environment. And really the best tool we have is energy efficiency, passive energy efficiency measures for the built environment. And it is our goal to spread the word of that, to do training as necessary, partnering with organizations like the New Jersey Clean Energy Program and a Clear Result, as well as others, our green building councils, to really just educate, not only contractors and architects, but also, stakeholders in the general public and in government. So with that, let me see, can we go to the next slide? Or is for the introductions? Okay. So again, thank you to John Nastasi and Ed May and Michele Calabresi. So before we get into the main event, we're going to have Michele Calabresi, who's from Clean Energy New Jersey program, say a few words about that program. Michele is the residential account manager in New Jersey, in the New Jersey Clean Energy program. He's worked in various energy efficiency sectors over the past 6 years. Including data centers, commercial buildings, and multifamily projects. He's a lead AP for BD&C and has a particular interest in the New Jersey efficiency standards being implemented throughout the Northeast. So we're excited to have Michele here, being interested in the Passive House standard and how that can complement their work. Before we get into that, though, I would like to introduce John Nastasi, who is the architect for the Candela Lofts project. And John Nastasi is both an architect and a design educator. He's principal of his own design practice, Nastasi Architects in Hoboken, New Jersey. He's built a diverse body of work, which is distinguished by a consistency of process, a rigorous detailed investigation of real and theoretical issues, and a high level of craftsmanship that accompanies the art of making. At the outset of establishing his own design practice, John's early work was recognized and awarded with the prestigious Young Architects Award from the Architectural League of New York. He's also an alumnus of Harvard's Graduate School of Design and a recipient of Harvard's Rice Prize in Architecture and Engineering. Over the years, John has held the position of director of the Materials and Fabrication Lab at Harvard's Graduate School of Design. And then in 2004, he founded the internationally recognized graduate program in product architecture at Stevens Institute in New Jersey, and has been invited to lecture and present his work and teaches at architectural schools across the United States. In 2015, John led a team of faculty and students in the design of the Shore House, which is the solar decathlon project by the U.S. Department of Education, which won, I believe, an unprecedented 11 categories during that competition, and the gold, grand prize winner of that competition. And as a result of that, John and his students were recognized by the State Assembly of New Jersey in Trenton. And his studio has also completed some storm resiliency electrical substations work with PSE&G utility, and obviously has completed the Candela Lofts project in Hoboken, which I believe is the first multifamily large-scale passive house project in New Jersey. So thank you to John for joining us. Very quickly, Ed May, who is a partner of Building Tip, he is a licensed architect and lead green associate. He received a Bachelor of Fine Arts from the University of Massachusetts at Amherst in 2001, Masters of Architecture from Parsons in New York City. He's an adjunct professor at Parsons in the New School University, as well as an industry professor at Stevens Institute of Technology in Hoboken. He directed the 2015 Solar Decathlon project for the Shore House. And in addition, he is one of our Passive House Academy teachers for both the Passive House Institute as well as the North American Passive House Network. Let's see, what else? Passive House, he's also certified by the Passive House Institute in Germany and the Passive House Institute in the US, which is FIAS, as a certified Passive House consultant. So with that, I would like to just turn it over to Michele from New Jersey's Clean Energy Program to say a few words. And thank you all for attending.
Thank you, Sean. Hopefully everyone can hear me okay. I'm going to share my screen. And should be sharing now. Put myself in slideshow mode. All right. Look good? Everyone can see me? Great. All right. So hi, everyone. My name is Michele Calabrese, and I'm with the New Jersey Clean Energy Program. Thank you to New Jersey Passive House and Passive House for having me on today. And today I'm going to talk a little bit about our residential new construction program. I know there's people from all over the country here, so this is a little bit New Jersey specific, but, you know, with these type of programs, there's programs, you know, across the country that do this sort of thing. So in New Jersey, we have the New Jersey Clean Energy Program, and we're administered by the Board of Public Utilities, and we're funded by something called the Societal Benefits Charge. So this is a surcharge on utility bills that help fund our program. And, you know, in New York, they have the Systems Benefit Charge with NYSERDA. You know, you have other organizations like Efficiency Vermont. I'm sure in your state, you're familiar with the organization. And Sean really touched on it already, but we have some really ambitious goals in New Jersey. So these programs are going to hopefully get us there and make us, you know, that efficient state that we're hoping to be by 2035, by 2050, and further on. So we have 7 main commercial programs and 4 main residential programs in New Jersey. I work on the residential side, but if you're in New Jersey working on a commercial project and you have questions, I can certainly point you in the right direction. We have counterparts who do what I do, but on the commercial side. We have rebates for existing homes. You know, we work on both existing and new construction. And on the existing side, you have your prescriptive rebates, which is, you know, installing X piece of equipment, homeowner gets X rebate. And we also have performance-based, our home performance program, which is, you know, whole home solutions. So things like air sealing, insulation, plus HVAC measures. And in New Jersey, we're really fortunate to have probably the most generous rebates. So we have a up to $4,000 rebate and 0% financing up to $10,000. So just wanted to mention these. They're always worth knowing. You know, not everyone's always building from the start up, but with residential new construction, the way our program works is our homes are evaluated by qualified participating raters credentialed through ResNet. And these rating companies work with the builders to build or reconstruct homes to energy efficient standards. So we can also have gut rehabs in this program. And essentially the rating company, their job is they're guiding the builders through every step of the way. So they're making sure all the paperwork's on time. They're making sure that all the checkpoints are built. And they're really alleviating the paperwork load because we all know with rebate programs, with permitting, paperwork's the biggest problem, right? Everyone hates paperwork. So the raters are there to help. And then the builders are receiving incentives for building energy efficient homes. And there's a website, njcleanenergy.com/RNC. I'm sure some of you are typing questions as we go along. And at the end, I'll have my email, so you can email me directly if you have any specific questions. And we have 4 levels of participation in the program. So we have Energy Star homes, Zero Energy Ready Home, Zero Energy Home Plus Solar, and multifamily high rise. Because the building stock in New Jersey is really, you know, we have really spread out. We have lots of multifamily, you know, you have things like the Candela Lofts in Hoboken. We have lots of single family homes. So it's a really unique market in that regard. And a lot of the homes can be very old. And, you know, if they're doing new construction or gut rehabs, there's a lot of work to be done. The benefits, thankfully, we have a very enlightened audience here. So I don't need to go into all of these. You know, we always get a little bit of pushback from builders who've always done things a certain way. So here I know there's a lot of great people already doing great work, but You know, the one I always like to highlight, increased market differentiation. If you're building passive house, if you're building zero energy ready, you're one of few doing it in New Jersey. So to be able to do that, if a homeowner is looking for the latest and greatest, there's not that many people they can go to. They're going to be able to go to you. And I know, you know, with these type of projects, the architects are always doing a lot of the work. You know, you're our best spokesperson. You're always pushing these homes, and we really appreciate it. And the homeowner benefits, you know, energy efficiency is something we're all familiar with. Homeowners know about saving money, but I think comfort's taken a new level in these last, 8 months. We've been in our homes for a while, a lot of us, and the idea of being comfortable in your home and how much more comfortable these energy efficient, zero energy, passive house homes are, it's a huge deal. We all know that room in the house that's too cold or too warm on this part of the season. It's just something we're starting to notice because we've spent a lot of time in our homes and we might be here a little bit longer. So those are just things that we always love to highlight. As far as eligibility, there's pretty much, you name it, it's eligible. Custom and production homes, single family, townhouses, and then multifamily on both the low rise and high rise. So if you're building in New Jersey, there's probably some sort of fit for you. So with this program, with our code compliance versus Energy Star, one of the things builders really like is we give them a little bit of flexibility. So they are able to just maybe change a few things that in the code that obviously you can't change mandatory things. But one example, they could put in a high efficiency heater and then the builder has the ability to install less efficient windows. Obviously it's not something you do in a passive house, but just something we'd see typically on our code compliance and Energy Star, giving the builder a little bit of flexibility to work in the program. Energy Star homes, as far as it goes with homeowners, these are great because homeowners know what Energy Star is. They've seen the logo on their fridge and they go, is that the same thing? And yeah, it is. And these homes are, designed and built to standards well above other homes on the marketplace. They're not as efficient as passive house, but they're a really good intro point. And, they're better quality, comfort, and durability. And, they're going through inspections, getting checkpoints, and they're increasing that home value in the future. We also have our zero energy ready homes. And, these are similar to passive house in a lot of ways, right? These are a semblance for excellence in energy savings, comfort, health quality. And these homes are so energy efficient that all or most annual energy consumption can be offset by renewable energy. And just like passive house, these are the homes of the future. These are what we want to see everyone building to. Passive house, zero energy ready homes, those efficient homes that really lower the carbon footprint and they lower the amount of energy used. Because like Sean said, the building stock uses a lot of energy in our state, and that's true everywhere. And the key characteristics on a zero energy ready home, you're building on the Energy Star home baseline, but it's a higher performance thermal enclosure. You also have really efficient heating, cooling systems, as well as lighting and appliances, and they're meeting that indoor air quality Air Plus certification. So the homes are, again, they're nice and tight. There's a lot of great indoor air quality. If your home's not tight, leaky and drafty, it's cold, but a lot of contaminants get in, can flare up asthma, things like that. And your typical homeowner doesn't really think of these things. So it's just something that we always love to mention. And, they're all ready to install PV, or if they're not already installing it with the photovoltaics. So the incentives, and I just go through these quickly just to give you an idea of what we do in New Jersey. So basically every single level from Energy Star, and I'd be pointing in the screen normally, but our new virtual world, Energy Star, zero energy ready home, and zero energy ready home plus energy, there's a baseline incentive. So on Energy Star, you get $1,000 no matter what, if you're doing a single family home. For zero energy ready, it's $4,000. For zero energy ready home plus renewables, it's $6,000. And then we give out a performance-based rebate on top of that. So $30 per MMBTU saved. And this is based on a model, obviously, since new construction. So the more efficient a home is, the more money the homeowner is going to have towards that work. And the builder, they're getting that money. So they're incentivized as well, because we also have incentives for multifamily. And these can be pretty lucrative. So you see $500 there for Energy Star. These are per unit. So if you're doing large projects, these really add up. We have zero energy ready home for multifamily as well. Not for multifamily high rise, but it's on that zero energy ready if you're doing a smaller multifamily home. This is another program I always love to mention. And if you're building in New Jersey and you've participated in our program, we have co-op marketing for builders. So if you know any builders who are doing work and want to participate in our program, it's a 50-50 cost share for eligible marketing measures. So basically up to $50,000 in marketing initiatives. Let's say they're doing some sort of print ad or television ad. They're doing a $5,000 ad. We'd refund them $2,500. So if they're working in Jersey and participating in our program, there's free marketing dollars out there for them. And, there's really no reason not to take advantage of something like that, because we always want more marketing for these programs. We want people to know about them, to be excited about that energy efficient standard, because we all know that that homeowner awareness is what drives the market. You know, builders here and in this room are probably more on the energy efficient side, more into this, but a lot of your common builders are kind of like, we've been doing it this way forever. Why should we change? So homeowner awareness, them being aware of what's out there, that's what drives the market. And these are just some of the raters who work in our program. You know, we always recommend reaching out to a few different raters for our people participating in these programs, because we don't regulate pricing. It's a dynamic pricing model. The raters can price as they see fit, and they all work in different ways. So it's a good idea. You have a meeting with a rater and get an idea of what type of work they do for you. But, you know, our programs, we're really fortunate to have great rebates, and they're very exciting programs. And we're pushing the standard forward with Zero Energy Ready. And, you know, that relates to Passive House, right? These are the homes of the future. We want people building these homes. There's my email. So I know I don't want to go into questions now because we have our Candela Lofts presentation coming up, but send me any questions you might have. I'm happy to talk. And if I can't answer them, I'll make sure that I can get you someone who can. But I just want to thank Sean for the time, and we can move on to the next presentation.
Michele, thank you so much. We really appreciate that. Very informative. And just so everybody knows, we will be hanging around on this meeting till about 1:30. So if anybody wants to chat or ask questions after the Candela Lofts presentation, we will be sticking around for a little bit. Now I'm pleased to turn it over to Ed May and John Nastasi. One thing I forgot to mention about the Shore House, it is on display, installed at the Liberty Science Center in Jersey City. So if anybody, I'm not sure if it's open, but if you're ever in the area and want to check out that award-winning Shore House that John Nastasi and Ed May worked on for the Solar Decathlon, it is open to the public. And with that, I'm pleased to present Ed May and John Nastasi.
Fantastic. Thanks, everybody. So let me see if I can share my screen, and let's see if you guys can see that okay. All right. How's that? Is everybody, can you hear me okay and see the screen okay? All right, I'm getting some nods. Fantastic. So thanks, everybody. And nice to see so many friends and colleagues on the call here this morning. Thanks to New Jersey Passive House and NAPHN for organizing this, and Sean and everybody else for setting this up. My name is Ed May with BLDGTYP. I was the Passive House consultant on this project. John Nastasi is here on the call as well. And I think I'll kick things off and talk a little bit about the project, and then we can sort of keep it open for questions at the end. And I'm sure John has some bits here to add as well. And of course, John, feel free to interrupt me at any point here in the conversation as we get started. So again, thanks to everybody for having us. I know this was supposed to be an on-site meeting, and I had actually, Sean, I had forgotten about that we had tried to set that up way back in March, and it was like that week that everything closed down. We were supposed to be on site doing this. Feels like a lifetime ago now. In any event, it's good to be able to do this virtually. Maybe someday we'll be able to do an in-person tour again. Be fun to have everybody come through the project for sure someday. So I'll be talking a little bit about this project. This is the Candela Lofts project. This was a certified passive house project that John Nastasi and our office completed a little while ago now. It was designed by John's office. Bijou Partners were the developers, and my office, BLDGTYP, myself and my partner John Mitchell, we were the passive house consultants on the project. So if you haven't seen this building before, I know we've presented it a couple times, but if you haven't seen this building before, if you're not from Hoboken, this is I think 7-story commercial development project, and it was a bit of an experiment for everybody involved to see if it would actually work as a passive house. You know, it was a real experiment. Nobody was sure if it was going to sell, if we'd be able to build it, if we could really make it work as a passive house. And so a lot of credit to the development team and to John's office for, you know, really taking the jumping in with both feet and trying it out. You know, as like I said, a real experiment, a test for everybody involved. It's a beautiful building, though. It came out really well in the end. You can see here, really fantastic design. It's a really dense urban neighborhood where the building is built, and is now a great home for a lot of folks in Hoboken. So successful building for sure. As I said, it was a speculative commercial property development, a very high-end condominium project, which is very different from basically any other passive house that we've ever done. Usually the passive house projects we're doing are owner developed. They're going to be single family homes for homeowners that have decided they want a passive house. This was different. This one, we were building it as a passive house, and we were going to try and sell it on the market as a passive house. And so that was a really different way of going about these types of projects, and definitely led to some wrinkles. But as you can see here, beautiful project, beautiful design, really fantastic project, fully sold. Everybody was really happy with how it turned out. So let me talk a little bit about the passive house side, and then we can talk whatever you guys want to get into. We can talk about the development side, we can talk about construction, etc. But let me talk a little bit about the design and the engineering on the project, just to sort of lay the groundwork, and then we can sort of talk about whatever side of the project is most interesting to everyone. So this project was certified to the International Passive House Institute certification, and for those who aren't familiar, passive house certification is just another type of green building certification, very similar to LEED or Living Buildings Challenge, Energy Star, as we were talking about earlier. It's another green rating system that prioritizes energy conservation, as well as health and durability and comfort of the occupants. So it's a relatively narrowly targeted certification that really prioritizes those few elements and does a really good job at those. We've been working the passive house standard for about a dozen years now, and had a lot of experience with all types of buildings. This was our first, though, of this scale for sure. And this building had a lot of challenges compared to some other projects that we typically work on. Number one, this building is in a very dense urban environment. So if you're not familiar with Hoboken, New Jersey, just across the river from Manhattan, it's about as urban as it gets. When you think city, this is what you're thinking about. It's in a warm temperate climate as far as PHI is concerned. So we have to struggle with both heating, but also cooling and dehumidification. Of course, a climate like New York City, dehumidification is a really big piece of the puzzle. And as I said, a dense urban neighborhood. This is an infill project. It's not a greenfield site. This is not, we're out in the middle of a potato field with all the ability to orient the building however we want. We had a north and east facing site, and that was how the building was going to be. Almost no useful solar gain on the project. That's actually okay on a project of this sort. And we had all sorts of challenges when it comes to the actual site itself. So right out of the gate, not terribly optimal as a passive house, right? We had a lot of constraints when it came to the site, not a lot of good solar orientation. Okay, fine. We're going to work with it. There's nothing you're going to do about the site. The site is the site. You're not going to spin the street grid of the city. Oops. The other real challenge, or one of the other real challenges on this project, was from a compactness perspective. So if anybody here is a certified passive house designer, in the training we go on and on about compactness of the building and how it really helps us to deliver cost-effective passive houses if we can form the building from the very beginning in a compact shape. Well, for all sorts of reasons, a lot of them related to the specific site, the street wall, as well as the zoning, and then, of course, flood issues in Hoboken. For all sorts of reasons, we were not able to build a terribly, quote unquote, compact building. So obviously we have to hold the street line on the north and east side there. We have some zoning setbacks to deal with. We want to carve out some outdoor space for the people who live there. And then we take the whole building and we lift it up off the ground. That's very typical in a place like Hoboken that suffers from regular flooding and of course suffered very badly during Hurricane Sandy. So right out of the gate, we have bad orientation or challenging orientation, and we have a challenging form factor because we're very exposed as a building. But again, these are kind of just things that are set, right? We don't have the ability to control these things. This is what the building is, and we have to build or engineer our passive house to accommodate. Just quickly, the floor plan of the building, you can see a representative floor plan here. Again, neighbors on the south and future neighbors off to the west side. In this drawing, north is to the right. So you can see the street front on the bottom and street front on the right-hand side there. Difficult form factor again for the building, but again, all related to the context of the building and how it was shaped to form itself to that urban site. But you can see the core and you can see the nice big living spaces there, which were great. And then lastly, of course, the biggest challenge was that this was going to be a commercial property, commercial construction style property, meaning concrete floor slabs, steel stud construction, not very passive housey, all things considered, right? When we build single family home passive houses upstate or outside of the city, we're using things like wood and cellulose insulation, fibrous materials, much more accommodating to designing out things like thermal bridges. We'll talk a little bit about thermal bridges if you're not familiar with that term. Very challenging construction type, in addition to really challenging construction environment. Very constricted site, not a lot of room, not a lot of space to move around. Really, really a difficult environment to build a building in at the best of times. And we were asking these builders to go above and beyond and do something that was really out of the ordinary. So hats off to the builders, to John's team for managing that side, and the actual construction implementation team. They did a great job with all of the crazy curveballs that we threw at them in terms of the actual fabrication of this building. And of course, from the engineering side, we did have to accommodate some of the, some of the things that were just set. We're going to use steel stud. We're going to use concrete floor slab. We're going to use a lot of steel. It's a concrete, or it's a commercial property in a dense urban environment. So we just had to work around that from a passive house perspective. Now, why is that challenging? Again, if you've gone through the passive house designer training, you're going to be familiar with this term thermal bridge. But if you're not, thermal bridge is just a break in the insulation layer. Or that's how the easiest way to think of it. And so think about something like a steel stud. If you're going to insulate the steel stud, around the steel stud, that steel is going to pass right through the insulation layer. So you're going to have a significant amount of extra heat loss as a result. On a project like this, or this specific project, we actually found that there was about 10% additional heat loss as a result of all of those thermal bridges. And that's after a huge amount of work by John's design team and our office to try and optimize these details. So this is after an incredibly rigorous, very laborious back and forth around the actual design and optimization of these details. So even in the best case, even after a tremendous amount of design work, we're still seeing about 10% additional heat loss as a result of those thermal bridges. And so we just have to design that in from the beginning. We just have to accommodate that. We have to do the engineering for the passive house design, knowingly incorporating those details. So how did we build the building? Well, the building is built with steel stud, backup wall. And then essentially what we did was we put a thick wool sweater around the entire building. So passive house prioritizes reducing heat loss in winter, reducing heat gain in summer. And the main way that we're going to do that is through lots and lots of insulation. I know that's not very sexy. I know that's not very exciting, but the fact is that insulation is probably the best, most cost-effective, easiest tool that we have in our toolkit to reduce energy consumption in buildings and improve thermal comfort. And so we put this big, thick wool sweater on the building. We use low conductivity facade connections. We design out those thermal bridges as much as possible with the recognition that it's still a commercial property development at the end of the day. Here you can see the construction team actually implementing that exterior facade wall, 8 inches of mineral wool over that steel stud backup wall. And then we have this sort of floating facade, which is only attached back to the building by use of these low conductivity fiberglass facade clips. So if you're not familiar, that's a system made by a company named Cascadia, obviously hugely laborious, right? A lot of work, a lot of steps, very difficult. And the first time that these fabricators and builders were implementing this technique. So again, real hats off to these guys. They did a fantastic job with it. The very first time they'd ever even set eyes on this system. So really, fantastic in terms of the final. But it was very challenging. They really did have to work at it, and it was very difficult. There's definitely a learning curve with a lot of this implementation. Here you can see the team actually installing, this is on the back side of the building there, 2 layers of 4-inch thick mineral fiber, mineral wool insulation over the exterior of the building. Mineral wool insulation, if you're not familiar, it's a fibrous insulation essentially made of basalt stone. It's non-combustible. The pests don't like it. It's a great material to use on the outside of a building, like the one here. Very durable, very resilient in many respects, and obviously really works very well as an insulation product. So 2 layers of 4-inch insulation. You can also see those facade clips, the black facade clips, they're holding those steel girts off the building. That's what supports the facade of the building in this case. Now, one of the other techniques that we use in Passive House world to reduce energy consumption, improve thermal comfort, improve durability, is to rigorously air seal our buildings. So in addition to super insulating the buildings, we want to make sure that they're as airtight as possible. That doesn't mean that you can't open the windows on a beautiful day. On a beautiful day, throw all the windows open, make it as open as possible. But it does mean that in a cold winter day, or a really hot, humid day, we have the ability to seal up the building, and we're able to manage the moisture that's coming in and out of the building, riding on those air streams. And so rigorous air tightness was one of the other things that we wanted to implement here, or that we had to implement here as part of the Passive House standard. And again, hats off to the construction team. They did a great job meeting those incredibly rigorous Passive House air tightness targets. Because of the way we designed the building, we were able to use this weather resistive barrier, the WRB, the weather resistive barrier, which is the main waterproofing layer. We were able to use that as the primary air tightness of the building with just a few modifications to the typical details. So we went a little above and beyond, but not a huge change in the way that we went about the air tightness of the building, just a little bit of thinking ahead and planning ahead. Now, when it comes to the windows, I think this is a really interesting detail. I like to show this mainly because it wasn't something I designed. This was something that the fabrication team and the installers sort of came up with. The goal here was to take a little bit of the insulation and overlap it over the windows themselves. So when it comes to window installation and detailing, one of the techniques we use in Passive House world is to take some insulation over the face of the frame. That's going to help us improve thermal comfort, improve temperatures, reduce condensation risk, as well as improve heat loss, so thermal performance. And the goal here was to take that insulation over the face of the window, and yet we still had this really deep reveal on the sides and top of the window. We had to somehow take the cladding and return it into that opening there without actually causing a thermal bridge. And what the team came up with was this detail where they have that floating steel angle, which is actually attached to the exterior structure and cantilevers back towards the building. It's able to fully support all the cladding and the trim without actually attaching or touching the building. So we don't have any thermal bridge in that case. So we're able to get the full improvement or the full performance of that overlapping insulation there. This is an example of the type of simulation and assessment that we do on these types of projects. Every detail is calculated and simulated for both interior side surface temperatures, so looking at condensation resistance, as well as overall heat flow and interstitial temperatures. So these lines here, if you're not familiar with these types of graphs, these lines show interior temperature distribution. So it basically shows you how the thermal energy is moving through the details. So we do this for all the different construction details, window details, etc. But again, here's that detail. I like this a lot. So you can see that steel angle cantilevering back towards the building, never touching the building, never connecting. We don't have any disruption of our insulation layer. So we get very good installation thermal bridging for our windows, very high surface temperatures, and really nice finishes. We get this really nice deep exterior wall, really nice shadow lines, gives a real weight to the building, which I think is really fantastic. Just in terms of implementation of airtightness, one of the things that we like to do wherever possible is mock-ups. And so this is the team actually mocking up and trying some of the airtightness detailing before rolling it out on the full building. This is obviously really important when it comes to commercial style buildings with lots and lots of windows to detail. You got to make sure that everybody's happy with these things beforehand before you progress to do the other 1,000 windows. And oftentimes you can't work that out on paper entirely. You got to go try it and see how it works. And so a lot of back and forth with the team to actually optimize these details, both for thermal comfort, condensation resistance, but also for buildability, right? We want to make these details accommodating to the actual reality of the on-site construction there. In terms of the actual detail, you can see here, belt and suspenders approach. We let the team do their typical exterior goop-based sealing. So they do like a sealant bead on the outside of the building. Fine, that's all per warranty. We're not going to monkey around with that. But what we will say is we'll give us a little extra. So on the interior side, let's supplement that goop-based sealant with some really robust and flexible tape connections, right? So as the windows are slammed and move around, as the building shifts around, we have a really robust and flexible connection for airtightness on the interior. In addition to that exterior waterproofing, that's all per warranty. We're not going to monkey around with that and make guys change that, but just give us a little extra, right? So we were able to design that detail in a way that was reasonably easy for the team to implement. And then just a couple last bits here. I'll talk a little bit about some of the thermal bridging. We'll talk about ventilation, and then we'll finish up and leave some time for questions here. So thermal bridging, as I said, one of the thermal bridge is anywhere that we have a disruption in the insulation layer, a break in the insulation layer. So things like steel studs, for sure, concrete balconies, that's another really common place for thermal bridges. And so one of the things we worked really hard on this particular project was to nip off the heat flow through those concrete balconies. We do that through these structural thermal breaks. So these thermal breaks get cast into the concrete floor slab at the time of construction, and it very, very effectively retards heat flow from flowing out of the building into those concrete balconies. Obviously, concrete balconies, incredibly important to urban buildings. We need this kind of outdoor space. When we're all locked at home, we recognize it even more. You know, that little bit of outdoor space is incredibly important for folks living in these dense urban environments, hugely important from a livability perspective, but we do have to implement it in a way that's not going to short circuit the thermal performance of the building, lead to things like cold interior surfaces, condensate formation, as well as, of course, a lot of energy consumption. So you can see here these structural thermal breaks. This is what they actually looked like installed in the building. So you can see them there after they've been cast in place. They sort of, you can see the sort of residue of them, or you can see them partially exposed there. But basically everywhere that we have these concrete balconies, which protrude through the insulation layer, we cast in these thermal breaks, these structural thermal breaks. Now, the one thing about these thermal breaks, they work great. You're not going to just drop them in at the last minute. These are obviously a part of the structural engineering. You have to plan for this early on. So again, real hats off to the structural engineer on this project. Again, didn't really bat an eye at the craziness that we were suggesting here, took it all in stride and was able to successfully incorporate these really, really well into the structural scheme of the building, even a difficult building of this sort. So you can see them here in a couple different places. So we have those guys installed. And this was actually a photo that I took on site. So in this case, I was actually standing outdoors on one of the balconies in a wintertime scenario. So it's pretty cold outside. It's 40 degrees outside or something. And this was late in the construction. So they actually had heaters running inside the building. So it was nice and warm inside the building, and it was cold outside. And you can see here how effectively those structural thermal breaks nip off that heat transfer from inside to the outside. You know, in a typical construction, we would see a whole band of heat loss on the outside of the building and a zone of very low surface temperatures on the inside of the building. Right? Those low surface temperatures, the result of excess heat flow, those would be areas where we would likely see thermal discomfort, but also condensate formation, potential mold growth. In this case, none of that, right? We just have a nice warm interior, super comfortable, super dry. And on the outside, we have very cold temperatures. It's not perfect. It doesn't perfectly eliminate heat transfer, but does a really, really good job of it. One other place that we really wrestled with on this project in terms of thermal bridging was actually on these sort of blind slab edges. So we have a building to the south of us, and we have we had to build up against it. But unlike in historic projects, you know, you think urban buildings, they're joined with a true party wall. Well, not so much anymore. Nowadays, when we build these types of buildings in urban environments, for all sorts of structural reasons, the code requires that we actually have what's called a seismic separation between our building and the next. So unlike old-fashioned buildings where the party walls are true party walls and the buildings actually join, nowadays we have a pretty good sized gap in between all of our buildings. It's big enough to allow a lot of cold air in, but it's not really big enough to allow a person to get in there and build it properly. So this was one of the real challenges that we had on this project, was how are we going to build these blind slab edges on the backside of the building here? And John's team came up with a really nice solution to this using these CH studs, which is a method used to build blind shaftway, fire rated stud walls. And the only real trick that we had in this case was that we had to cast in place one of these structural thermal bridges, or structural thermal breaks that we use on the balconies, except we had to use a special version of it, which is not for balconies, but for these slab edges. You can see here, there's no sort of extension out to the balcony side. Instead, it turns back on itself and just allows us to get that structural thermal break at that slab edge. Allows us to fully isolate that slab edge from the rest of the building, get good thermal continuity there, get good interior side surface temperatures, low risk of mold growth or moisture condensate formation, and the rest. Challenging, to be sure. Again, the installer teams really had to figure out, how are we going to build this from the inside out without actually being able to get a person ventilation out in that weird little gap, very, very challenging. This was something, again, that the installers came up with and John's team came up with on the actual site there during construction. And then just lastly here in the last 2 minutes before I know we're getting long here, just want to talk a little bit about the ventilation system for the building. In addition to, a really, really robust envelope with excellent windows and low levels of thermal bridging, good air tightness, and lots of insulation, one of the other core strategies for building a successful passive house building is to implement dedicated fresh air ventilation system with heat recovery. So we want to bring fresh air in all day, every day, and we want to take stale air out all day, every day. And we want to do that in a way that minimizes energy consumption and the risk of over drying the interior air. Obviously, we all know a lot about the risk of over drying interior air and things like virus growth and respiratory problems. But that's been a core part of the passive house world for many decades now. And so we implemented just such a strategy here. Because this was a condominium project, instead of having one big ERV or HRV, a heat recovery ventilator or energy recovery ventilator that served the whole building, which is maybe how we would typically do a building of this size, instead we decided to use a distributed strategy where each unit got its own ERV or HRV, its own ventilation unit with heat recovery that brings fresh air in all day, every day, and takes stale air out all day, every day, resulting in really, really high quality indoor air, very healthy environments. The one challenge here was that we didn't want 1,000 penetrations coming through the facade of the building. Obviously, you saw the facade of the building, beautiful facade. We didn't want a bunch of penetrations just poking through willy-nilly everywhere. And because of the location of the HRVs, it was also going to be really difficult to reach the facade of the building. So we actually used a strategy here, which I don't think I've seen on other projects. This was definitely something of an experiment. We used these two shaft ways through the building to actually bring fresh air in and take stale air out. And so rather than penetrating the facade of the building with really long duct runs, instead we used very short duct runs and we connected to these insulated and airtight shaft ways through the building. And we had lots of those connections, one for each unit in the building. We did have one rooftop ERV that served all the common spaces in the building, the lobby and the hallways and etc. And so that was up on the roof. But for the most part, all of the actual dwelling units are served by their own individual ERV with its own filters, its own controls, and its own access to the outdoors there. This was quite a complicated detail to work out. Again, a lot of this was worked out on the site with the installer team, with John's design team. You can do as much of this detailing ahead of time as you can, but then and when it comes time to actually build it, it's always a little different than you thought it was going to be. So a lot of this ended up getting worked out on the job site. Again, hats off to the design team and the installer team for flexibility there. But essentially, we have the ARV and it connects over to these shaftways. The shaftways, of course, had to be really well insulated and air sealed, both to prevent condensate formation, any risk of mold growth or condensation there, because obviously you have ducts full of cold air running through a building, but also to reduce the amount of heat loss that we saw in the building. So a lot of coordination, a lot of back and forth, a lot of different techniques that we use there to implement that, but it worked really well in the end. And then just the very last thing here, one thing that I've never had to wrestle with before on a building, this was our very first time ever sort of wrestling with this, was the garbage chute. And you think, wow, that's so stupid. Why is that even, it's such an incidental thing? Well, not really. You have a giant steel tube full of outdoor temperature air running through the middle of your passive house building. So you have to think about, how are you going to air seal that? How are you going to insulate that? How are you going to avoid condensate formation and potential mold growth? And of course, how are you going to avoid the smell from the garbage room coming back into the space, right? The quality of life in these buildings is incredibly high, and we want to maintain that. So really thinking through all of these details is really, really important. So we experimented with a couple different versions. In the end, we actually built what's called version 1 on this slide. It's essentially an outdoor air shaft that runs through the entire building. There's all sorts of very, very specific code language about how you do these big shaftways. Obviously, these are, key when it comes to fire prevention and protection of the interior. So you always have to keep in mind all of those fire protection rules and regulations when it comes to these types of things. But in the end, we were able to get the team to insulate and air seal these chutes. You can see in the photo on the right-hand side there, these chutes come to sight as these big preformed sort of steel elements. And the real weak link in this whole shebang are the doors. It's very hard to get a good airtight and thermally isolated or high performance door to a garbage chute. It's just not a thing that's available. And of course, as you can imagine, you can't really make one on site. These all have to be UL listed components. They have to be really highly tested for fire prevention, because obviously a shaftway like this is, again, a real weak link when it comes to fire propagation throughout a building. So, we did what we could. We weren't able to eliminate heat flow and thermal bridges entirely. So we just design in and accommodate the excess heat loss at those locations. So, do what you can and try. Maybe on version 2, we'll come up with a better solution for the next one. But right now, the garbage chutes are definitely a weak link in the whole strategy there. But, we do our design and assessment. We budget it in. We add in the heat flow. We, do the condensate assessment, et cetera, and think through. So that's all I have. I know I went on and on for a while there, but John, if you want to maybe talk for a few minutes about the development process and the different characters involved, I think that would be great. And then I understand we'll have some time for questions and answers. So sorry for droning on there. Hope that was okay. And yeah, thanks for coming to this event.
So Ed, I would love to share my screen. Do you want to unshare
Yeah.
and then I will share?
Absolutely. Do that. There we go. All right, you should be.
Okay, I'm good. Thank you very much. And Ed, it's nice to see you on Zoom. I haven't seen you in a long time.
I know, nice to see you too.
I have to thank everybody for inviting us to come and present the Candela Lofts to you. It's always nice after a very difficult project to listen to Ed give a presentation and make it seem so easy. And it's always wonderful to work with Ed. I also want to thank Ed for not outing me of having 14 corners per floor in every residential floor. He sort of dragged me in the mud during his last presentation, but he let me go easy a little bit on this one. But I thought, I've been working with Ed for over 10 years. We've worked on three academic solar decathlon houses together, which span 6 years. And then if you throw in the Candela Lofts at the end of 3 solar decathlon houses, Ed and I have been working together for over 10 years. And it's always enjoyable to work with Ed. He's a wonderful guy. So look, there's nothing that I can say about this building in the spectrum of passive house that Ed hasn't covered, but what I could do is I could literally zoom out. So, and I would just like to fill in a little bit for everybody, sort of the context for which this project happened. So for all of you who don't know, this is Manhattan, and Hoboken is a little 1 mile square city of 55,000 people directly across from Lower Manhattan. It's very dense, as Ed mentioned, but what's very important to know is that the entire back of town is at about elevation 4 sea level. So FEMA has come in since Sandy and laid down a series of requirements that we've had to follow. And the city of Hoboken has really gotten on board, especially because of Sandy, in that the whole northwest of Hoboken is sort of this progressive engineering feat. The city has invested $100 million in a 6-acre storm resilient park between 12th and 13th, between Adams and Madison. So during a rainstorm, we will collect hundreds of thousands of gallons of stormwater, and then the North Hudson Sewer Authority, with its electronic valves, will dump this stormwater back into the sewer system long after a storm event has happened. It's an amazing feat of engineering. Coupled with that, I'm working with PSC&G right here, and we're in the final months of constructing a fully storm resilient substation for the city of Hoboken. So in the past, every time there's a storm, the infrastructure of the city would flood and everybody would lose power for a week. And PSC&G in acquiring property from the city is building a fully storm resilient substation that's 16 feet up in the air. We were the architects for the project, and it's in the final legs of construction. And then if you see the storm resilient park, the fully storm resilient substation, Candela is right here. So we have a beautiful little enclave, which is a post-industrial section of town that is really kind of embracing 21st century engineering methodologies. So Candela is really a blip on the screen of a much broader effort by the city of Hoboken. And that sort of formed the context for when we approached the city of Hoboken and said, we want to build a 7-story passive house building in a redevelopment zone. And the city, it was Mayor Dawn Zimmer at the time, Mayor Ravi Bala now, they fully embraced our efforts and made the arduous approval process as simple as possible. So we're starting to develop like an engineered neighborhood over here, and that leads me to my next project, which Ed will get dragged into at some point, which are these 2 city blocks which front the park. So these will be sort of state-of-the-art buildings. Those are coming through the approval process, and it sort of wraps and envelops this park. So these are the kinds of broad things that I'm dealing with while we're diving in and engineering the details in the engineering at Candela. So, and I will say all of this happened, and for all of you architects and educators out there, all of this happened, believe it or not, because Ed and I were building a tiny little solar decathlon house in the parking lot at Stevens Institute. And this was where Ed and I taught together at Stevens. This parking lot was our job site for when we built solar decathlon houses. And because we were building the Shore House here, somebody was walking by in the evening, saw what we were doing, and approached us probably in 2013 or 2014 and said, can you guys build a 7-story version of that Shore House? So the presentation that Ed gave you was really, it came from an opportunity that arrived right from the Shore House. So I think the last thing I would say is that, as architects and developers, you always have to embrace any kind of design challenge. People are always putting design challenges at your feet, and you have to be ready to sort of embrace the opportunities that come with these design challenges. So that's the only thing I would like to add to this mix, and I'm sure you have a ton of questions for Ed, or if any for me, that's fine, but thank you.
Excellent presentation. Thank you, John. And thank you, Ed. And John, I mean, especially, putting it in context, how these projects have really, stemmed from the Shore House, I think is really amazing and really cool. So excellent presentation. Ed, really great details there and some of those difficult conditions. So thank you guys. At this point, we're going to open it up for questions. Madeline, do you have a list of questions, or is Gall doing those?
I have a few questions. Actually,
okay.
You guys did a good job. There were only a few questions, so maybe we can go home. We can all build passive houses. But yeah, there were a few questions. One question was, what installation material was used for the cast-in-place structural thermal breaks?
The specific product, those were Shock Isocorb structural thermal brakes. So there's a couple different manufacturers that are able to supply those, but the specific ones that we used on this project were from a company called Shock, which I believe is a French conglomerate engineering team of some sort.
Yeah, do you know what material they are exactly?
No, it's some sort of really high density polyurethane foam, I believe, some sort of, the actual structural thermal break elements are, it's sort of a big rectangular element, and it's got a bunch of stainless steel rebar that sticks out of both sides. The stainless steel rebar on the top side, on the tensile side of those cantilevered balconies, is continuous. So you still have rebar that goes through, stainless steel, so less conductive than mild steel. But then the bottom side, the compressive side of the cantilever balcony is essentially held in place by this really high density, I believe it's polyurethane foam, but don't quote me on that, could be a different type, but it's some sort of really high density foam that's able to withstand the compressive loading of those cantilever balconies there.
Thank you, Ed. Justin, do you want to ask you a question about the trash chute?
Sure, no problem. Hi, Ed, how are you?
Hey, Justin, what's going on?
Okay. No, it was just, so were there other restrictions on the size of the trash chute so that you couldn't like actually create a full room? It had to be only the chute itself? Because I imagine if you were to actually create a room with the actual like door that you could then, more easily separate that out from the rest of the envelope.
Yes, yes, that's a good point. Yeah, I think on this one, because there were only a few units per floor, we didn't have, if you were doing like 100-unit building, maybe you would have an actual trash room on every floor. In this case, we just had a trash chute access almost directly from the very small hallway on each floor. So we didn't actually have a room, and that was for space reasons. There was all sorts of reasons why we didn't want to sacrifice a bunch of extra space for only a couple units per floor. But on a larger project, if you're doing, if you've got 30 units per floor, I think you're totally right. You would actually do like an actual room, a garbage room, where you could collect that and you could more easily sort of seal that off from the rest of the building. Yeah, I think that would make a lot of sense. The difficult thing about the trash chutes is that essentially, my understanding, by code, they have to be completely open on the top. You can't put any sort of damper, you can't put any sort of closer. It's essentially just a big open hole through the middle of your building, and there's no ability to seal it off. I mean, you put closer doors at the bottom and things like that, but they're not airtight. And so yeah, it essentially just a giant steel hole through the middle of your building. So you have to manage that somehow, some way.
Thank you. Brad Griffith, you had an interesting question about the financing. Is Brad there?
Yep. Ed had mentioned that this was a bit of, I think it was Ed that mentioned that this was a bit of an experiment. And I was wondering how you obtain developer financing, and if these were owner-occupied condominiums, what the mortgage market thought of this experiment.
Sure. Well, John, you know more about that than I do. Why don't you go ahead and take that one?
I think this was an interesting situation because it was actually the developer who came to us and asked us to do a passive house. So we didn't have to sell the developer on passive house methodologies or the benefits of passive house. So you had a developer who had already bought in, like philosophically. So that kind of made the project a lot easier. But then the developer pretty much got traditional financing, and then all of the units were sold and people got traditional mortgages. So once the design team, bought into building a passive house building, it pretty much became a very typical development project. So the methods of passive house did not create problems at all for a financing standpoint.
The one thing I'll add to that, and maybe John, you can speak to this too, there was some work that we did with the sales side. So when it came time to actually start to sell these things, one of the things that our office had to do was give a little mini, like a couple actually, of primers to the salespeople, the real estate agents, because obviously passive house is something new. It's a huge amenity, it's a huge benefit, but you have to learn the lingo, you have to learn the ability to sell that and actually communicate that properly to the potential buyers. And so we did have to do a little bit of education on the real estate agent side to get them up to speed.
I think that's a good point because, we're in sort of post-assessment, mode right now. Everybody, the 9 units are fully occupied. They were all sold at the top of the market in Hoboken. There's very nice progressive people in the building. And I cannot be honestly tell you, I can, as the architect, say the impact that passive house had on the sales was X. We kind of don't know. And as the design team and the developers, we just sort of chalk it up to that. It was like one complete package, and the passive house contributed greatly to the marketability of the building. But I would be lying if I told you that buyers came in and said, I absolutely want to live in a passive house building. It just made it that much more a reasonable proposition to buy into a building like this because, because of its low energy. It was just a very smart building and sort of beautifully detailed. But that's I think the big takeaway for me is how big of an impact did passive house have, because that's what all my subsequent clients are asking me. And it's hard to put your finger on it.
Totally. Do you know, John, and correct me if I'm wrong, but we started this project so long ago, I don't believe that any of the financing was through any of these incentive programs, was it? I don't believe there was any sort of incentive financing that contributed. So
not at all, because the developer Bijou, Larry Bijou and David Gaber of Bijou Properties, are serious developers in Hoboken and have done some beautiful buildings. They were producing LEED buildings at the very beginning of LEED. So they were kind of ramped up to doing green buildings, and they have their whole, financing arm that does this, and it wasn't through any of those programs.
John, there's another related question here about, have you gotten any feedback from the occupants related to the pH aspect of the project?
Well, I think that's, I think that's a fascinating question, because as we head into the winter, now we have the building fully occupied. I'm in touch with the majority of the owners. Larry Bijou, the developer, is in the penthouse. So we're going to continue to monitor and collaborate with these occupants to get their feedback on what's working, what's not working. And that's what I'm really fascinated with. Ed and I have always talked about a post-occupancy, monitoring, program with students that maybe one day we will launch, but I think that's a fascinating thing. It's a fascinating thing for architects to get into, so that architects don't have to end their work at occupancy, but they can stay on board and start to deal with post-occupancy monitoring.
I can add to that. Definitely, we've heard. So I've heard from Matt Testa. He's he was the primary construction manager from the developer's side. He has said anecdotally that he's heard from many of the clients, this isn't like a rigorous study or anything, but just anecdotally, he's heard that the main comment is in regards to the indoor air quality, and a lot of the general public doesn't have the language to speak about these things. So oftentimes people can't put their finger on exactly what it is that they feel in these buildings. And he's essentially said just that. He's hearing from people that they really like it, that there's something about it. There's something about the feel of the interior of this building that's better and awesome. And they can't put it into words. They don't have the vocabulary to say, oh, it's about thermal comfort and lack of temperature asymmetry in the space. That's not a thing that people can talk about, but they can tell that it's a lot more comfortable, and there's something about the air that's fresh, obviously, because we use a dedicated fresh air ventilation system. But again, they don't necessarily have the technical vocabulary to speak about those issues, but they can tell that it's a better, higher quality building, that it feels better, that it's more comfortable, that it feels healthier. And that's certainly what we've heard anecdotally. But yeah, we don't have like a whole data set or something to justify that. That's just through the grapevine.
Right. We had a couple questions here about the exterior facade. So Gary Mosier and Steve Mann had a question. First one is, what are the facade panels? What's the cladding? And then how did you finish the facade in in that blindside application? Next to the adjacent building.
Well, two things. The first question is the building is a cementitious rain screen that's suspended off the edge of the slab, as Ed described. So they're composite cementitious panels that are face fastened into a metal substrate. And I think for the past 5, 6, 7 years, most of our buildings are using rain screens with sort of zero maintenance cementitious skins and allowing us to get the insulation outboard of the building envelope. The H studs that Ed was talking about on the south elevation is really shaft wall construction, kind of like commonly known as shaft wall construction, and it allows you to build up against neighbors' walls, so it's sort of self finishing. So it's just a raw shaft wall sheathing, in that tiny little gap between our neighbor to the south.
I should note also in regards to that one, I was talking about that seismic gap. I mean, we did do the traditional M seal up around the perimeter. You would typically use this expanding foam fireproofing product to actually seal from you to the neighbor when you have a seismic gap like that. And, I don't have anything against M seal. It's a great product. They have an amazing amount of testing that shows how airtight it is. I was skeptical. We had just hadn't seen any documentation or research around the air tightness in a gap like that. And so in all likelihood, it probably is a relatively closed space. The M seal probably works perfectly well. Obviously their testing shows that it seems to work really well, but not having any independent testing, not having done a building like this before, we decided to do a belt and suspenders approach. And so that was why we sort of approached it that way. So it's probably overkill to do the thermal isolation and the this and the that. But, again, not having a big data set of buildings like this and a lot that we could point back on and say we'd done those details for 20 years, we were sort of, going a little above and beyond. And again, a sort of belt and suspenders approach there.
Yeah, and just to clarify for those who may not know what M seal is, it's an impregnated foam expansion joint. Is that correct?
Yes. Thanks, Sean. Yeah, sorry, I shouldn't use so much jargon without explaining. Yes.
Okay, I think the only other question, we just maybe have a couple more questions here. John Kramer is requesting a link that may show more pictures from the interior. Is that at the Bijou Properties website, or do you guys know?
I think you can look at candelalofts.com.
Okay.
There's a series of that's the marketing website, candelalofts.com.
Okay, and then we have another question here from Steve Mann. How early on in the design process did you decide to pursue low energy certification versus classic certification? Yeah.
Well, you're getting into the weeds now, Steve. So everybody who's not who's not interested in like the real wonkiness of certifying passive house buildings, put your fingers in your ears for a second, because I'm going to talk about some real weed stuff here. So low energy building certification, the main difference between the low energy building certification and the classic certification, which was what we were originally going for, is that air tightness limit. So air tightness for a classic construction is 0.6 air changes per hour. For low energy building, it's 1.0. All right, that's the biggest. There's some other differences. There's difference on the heating demand. The main difference for our purposes was that air tightness limit. Now, what happened in this building is that during construction, we were right up against the end. People were buying units and starting to move in as the building was still getting finished. So the difficulty of doing these types of multi-unit buildings is that there's no good time to actually air tightness test, to blower door test the whole building. We had done a bunch of interim blower door tests up to the end, but there was no chance for us to actually or blower door test the whole building because people were already living in part of it. And so what happened was we did a blower door test. We got like 0.8 or something like that. Not great, it was darn good, but it wasn't exactly to our where we wanted to get to. We made a bunch of edits. They fixed a bunch of doors and fixed a bunch of stuff with the windows where we knew there were problems, but then there was never another chance to blower door test the building. So we never, because people were living in it, because it was then occupied, we never had another chance to air tightness test the building. I'm fully confident that we would exceed that 0.6, but there was just never a time to do it. And so as a result, we ended up getting that low energy building certification merely because we just never had a chance to actually air tightness test the building. And I don't want to say that this is, this is actually a problem that we're going to run into a lot with these larger commercial and multi-unit buildings. It's very common to do phased certificates of occupancy where you're going to start to inhabit one piece and then the other. It's something that I know Stash Zashevsky has talked about with his project there on 25th Street. This is a problem that in passive house world we're going to need to figure out a solution to, because these big buildings, they're not like single family homes. There's not a chance. There's not a point where like everybody's out and you just have the whole building done and you have a chance to air seal it or air tightness test it. These buildings they're inhabited in a different way. And so that's how okay. So everybody, you can take your fingers out of your ears now if you're not part of if you don't want to get into the real wonkiness of the certification. But that's how that came about. So we ended up with that low energy building.
If I remember correctly, Ed, Matt Testa and Juan Rodriguez, Juan was the architect in my office full time on the job site. They had fixed the lift slide doors.
Yes,
and that would have, I think if we would have retested, because those lift slide doors relatively speaking, we're letting a lot of air in. And then once we fixed it, the building got tighter, but we didn't get a chance to retest the whole 7-story building. But I think we would
That's
have
correct.
because those lift slide doors were the culprit.
Yes, and it was well known. I mean, at the time that we did that final, you're totally right, John. And at the time we did that test, the lift slide doors actually weren't latching. If you remember, like they were, those lift slide doors are very difficult. You have to adjust them sort of perfectly. They weren't even really, you couldn't even latch them. And so we knew exactly where the air leaks were coming from. It was because those doors weren't adjusted yet. They got adjusted. They all latch, they all close perfectly now, but we just never had a chance to go back and retest the building. And so that's really how that ended up. So I'm 100%, I'm confident that it's in a great shape, but we never had a chance to retest it.
And I would add, we'll put my architect's hat back on. Those lift slide doors were 8 feet tall, 16 to 20 feet long, because we're architects, right? And then as soon as they were leaking, we're like, okay, why did we put 8-foot high by 16-foot long lift slide doors? And so, fixing the air infiltration and those things is not an easy task. So we were always balancing, our architecture, objectives with our engineering objectives.
Thank you. While we're on the subject of air tightness, just for a little context, we're talking about 0.6 to 1.0 air changes per hour. Do you know how that compares to the current code in New Jersey?
Well, if I believe the code, and I mostly work in New York, so forgive me if I'm wrong, but the code is mostly 3 air changes per hour, except you don't have to test anything. So it's like a Scout's honor, 3 air changes per hour, which really means like 7 or 10, right? If it's like, oh, did you build it to 3? Yeah, I built it to 3. Okay, good. Like that's basically how the codes work right now. And it's the same in New York, same Massachusetts, same everywhere. So I believe it's 3, I think.
Yeah, I think you're right. So, just for context, that's, obviously significantly tighter than code. And obviously, air leakage is a major issue for thermal losses and heat loss and energy loss, as well as condensation issues. Gall, you had a question about thermal bridging?
Yeah, I was wondering if from your calculation, at least the thermal bridging for heat loss and heat gain had the same effect, or was it different effect?
That's an interesting question. Again, if you're not interested in the details, put your fingers in your ears for a second. The thermal bridging absolutely affects you in both directions. The thermal bridge correction factors are just a measurement of the effect of heat transfer through those details. So it's going to affect you in both directions, both in terms of heat gain and heat loss. I don't care about it very much when it comes to heat gain, though. The issue with thermal bridges is that you have a bunch of heat loss, but you also have these low surface temperatures, which are a breeding ground for mold and condensate formation. And so when it comes to thermal bridges, that's the main issue with thermal bridges. Yes, we want to budget in the heat flow. We want to accurately assess heat loss. But the real issue from a building science perspective, from a health and wellness perspective, is that we want to avoid that mold and moisture formation wherever possible. That's not going to happen in the summertime. Those thermal bridges are not going to affect you in the same way. You're not going to see that condensate formation and that risk of mold growth in the summertime. That's a wintertime issue when it comes to thermal bridges. So yeah, they're going to play a very small part in your heat gain in the summertime, but really it's about mold formation, moisture, condensate risk in the wintertime. That's our main criteria when assessing those thermal bridges. And of course, we want the accuracy of those correction factors.
Thanks. I'm trying to think about it. I'm just because, cold air coming out and hitting a piece of metal might still create condensation inside the wall. But yeah,
well, in the summertime, it's 85 degrees outside and it's 75 degrees inside, or maybe it's 90 degrees outside with 75 degrees inside. So your difference in temperature is just much, much smaller in the summertime than it is in the wintertime. And your likelihood of achieving the dew point is very rare in the summertime, unless you air condition your building to 65 degrees or something in the summertime, which hopefully you don't, or you live in a place like Miami, which has an extremely hot and very humid exterior. It's very climate contingent when you might see those issues, but you do have to take into account the climate effect there. Yes, there's a difference in temperature, but it's much smaller. In the wintertime, it could be 0 out and 70 inside. So you have an enormous difference in temperature and a very real risk of your interior air, reaching its saturation dew point and seeing condensate formation and high relative humidity there.
Got it. Thank you.
Great. I think that's all the questions we have on the chat. Are there any other questions for Ed or John or
I'd like to
Kelly?
throw out a quick comment. I've got to jump to another meeting in a second. I want to thank John and thank Ed and New Jersey Passive House for hosting this great event. And I also want to give a plug. I think, Ed, you are one of the instructors for the CPHD happening November
Yes, indeed.
16th on you.
Yep, that's right.
Another plug for Ed here. If you like his teaching style here, be sure to take the class the week of November 16th. It's a great course. And with that,
Thanks.
I'm going to sign off. Thank you, guys. Thanks, everybody.
Thank you, Ken.
Thanks, Ken.
Thank you, Ken.
Okay, so if there's no more questions, I want to thank everyone. Oh, we do have a question. Looks like this is for John and Ed. What is your next project that we should look out for? From Whitney Davis.
Yeah, I don't know what's on. We'll see. We've got a whole bunch of them in the works right now. I don't think anything quite as high profile or spectacular as this one, but a lot of other smaller projects at the moment.
Yeah, there's a couple of things that we're dealing with. One is a 30-acre resort out in Suffolk County on the water, and another is a large residential development in the Midwest in Colorado, and they're all building on the momentum from Candela. And then, once we get some traction on those things, then of course my first phone call is always to Ed to bring him on board. And we're trying to go from the 10-unit building, 9-unit building to Candela to maybe like a 30-unit development that's all passive house. And I think that would be like a wonderful thing to do. We have a place out in Suffolk County on the water that's in like this beautiful marsh area, and we want to do a super eco clean resort that would be 100% passive house. And that's something we're at the very beginning stages of, that I'm working with a very good developer client on this one. Hopefully that's the next one.
Excellent. Well, thank you for, I think, everybody agrees this was an incredible presentation. We thank you for your time and your expertise. Both Ed and John, thank you. Please keep us updated on upcoming projects. Anyone who can, who's in the northern New Jersey or New York City area, we highly recommend going to check out the Shore House exhibit at the Liberty Science Center in Jersey City. I want to thank as well Michele Calabrese from New Jersey Clean Energy for his time. Feel free to send an email to us or reach out to us if you have additional questions or need anything, or just general interest in Passive House and our events. One other plug for NAPHN. We're always looking for members, like-minded professionals, or just normal people and citizens of New Jersey to join us and help educate and implement Passive House, both in practice, but also from a legislative standpoint. So please reach out to us if you're interested in becoming a member of the New Jersey chapter of NAPHN. And again, as Ken mentioned, please look into the Certified Passive House Consultant Designer training coming up that Ed May will be teaching. So again, thank you, John. Thank you, Ed. Thank you, Michele. We really appreciate your time, and have a great day, everyone.
Thank you very much.
Thanks, everybody.
Thanks a lot.
Have a good day.